Good morning, everybody. Welcome to a cloudy but fun day of chemistry, Chem 1105, with your host, me, Dr. White. Now, one of the things I did last week, I talked about, and I sent out an email to anybody who's missing lab scores. You have until Thursday, I think 4 p.m., to get your labs that you haven't handed in. To me. If the link is closed in the assignment area Blackboard, email it to me. If you need a copy of the lab because you don't have it, email me and I'll send you it. But after Thursday, you will get 0 points if it's more than 8 days late. Also, don't forget to hand in the lab that's due tomorrow, because starting this week, I will be enforcing my syllabus. I've been pretty lenient so far, no more. Ooh, I sound tough. Well, yeah, I am. On this, I have to, because a lot of you are going to lose a lot of points, which will hurt your grade. But a lot of you are also handing in the lab, so thank you. Remember, all labs are 10 points, and unfortunately, unlike face-to-face, where I put a red line through something that's wrong, if you have a question, why'd you take off points, email, see me during my office hour or after class. Don't forget tonight at 5 to 6:15, I have my office hour. If you need any help for anything, come on by. All right. Now, I was debating and I decided no, it wouldn't be fair to you to move the test back even closer to this Friday, but you wouldn't have had last weekend to study because I would have told you today, which I don't think is fair. So don't forget, a week from this Friday will be test 2. Test 2 will cover chapter 4 and chapter 5, part 1. And test 2 is usually the lowest average test of the semester, but not always. Therefore, I highly recommend you take this extra time to do the practice problems on your own. Tomorrow, tomorrow, I will go through chapter 5. Come on, get out there. Chapter 5, part 1. Tomorrow, I'll go through the problem set and make sure you try them before I do, or at least try them. What did I say? Try it, you'll like it. I just did a generation gap on you. All right, now we're moving ahead. I'm going to be talking about gases today. That will not be on test 2, it will be on test 3. Now, last week we started talking about gases, and key property of gases are pressure, volume, temperature, and amount. And I started talking about temperature. And temperature, by definition, and this will never be on a test of mine, is the force applied per unit area. That's the total force of a surface divided by the area of that surface, which in equation form is pressure, P, is equal force divided by area. Well, guess what? We have gauges to measure this, or sensor devices to measure this. And what is important is the atmospheric pressure. And the atmospheric pressure, as I showed you last Friday, is measured in our homes at least, and in the lab too, by what we call barometer. And a barometer is the device used to measure atmospheric pressure. Now, at the atmospheric pressure, there are 2 ways of measuring it, or units. One is millimeters of mercury, excuse me. Now let's see if I can bring up the barometer. All right. Thumbs up, people. Help me out. Oh, no, but he has their webcam on. No, it's turn on your webcam Monday for Dr. White. Wonder if that worked. Not really. But anyways, thumbs up, people. Thank you, Taylor. All right. Now, this is the classic original barometer. I forgot who invented it. Let's find out. Ah, I should have known. I thought so, but if you notice, the barometer, and then they call it a physicist, but I think of him as a chemist or a scientist, is Torricelli, the Italian scientist. And how a barometer works is you've got a vacuum tube that's, to begin with, empty. And then you have a bowl or a container of mercury, which you put the end of this vacuum tube when it's empty in that dish. And you have a clamp to hold it. And when the atmosphere pushes down on the mercury, it has it go up in the tube. And this distance from the top of the level of the pool of mercury in the dish to the top of the mercury in the tube, you can measure. Now, notice here on this picture, it's 29.92 inches of mercury. Hg, you know, is mercury. In science, we use the metric system, which would be millimeters of mercury, mm. Now, in honor of the work, the invention of Torricelli, I don't know when, but scientists or chemists decided to also have a unit called the torr, which is short for Torricelli. And I hope I'm pronouncing his name right. And you should know one millimeter of mercury equals one torr. And that's the definition. So both number one are exact numbers. Now, it turns out in chemistry, and I guess other things too, an important measurement of the barometric pressure, the atmospheric pressure, is at sea level. And for those of you who are wondering, essentially Chicago, is this about considered sea level? And 595 feet above sea level is really sea level. Now, sea level is a benchmark, and what was defined, the atmospheric pressure, assuming there are no storms coming through, as sea level is defined as 760 millimeters of mercury. So sea level atmospheric pressure is 760 millimeters of mercury. Now, 761 millimeter mercury equals 1 torr. Therefore, 760 millimeters mercury equal 760 torr. Now, what this really means and plays an important part in understanding gases is the following. By definition, 760 millimeters of mercury equals 1 atmosphere. ATM is shorthand for the unit atmosphere. And look, I even wrote it on the slide. Know this. Now, good news. Since I've been, a couple years ago, cutting down on memorization on my test, but expect to know how to apply things, on test 3, I will have the following. .760 torr equals 760 millimeters of mercury equal 1 atmosphere. And even though I write, know this, I really should write, you should know how to use this. This is extremely important to gases. Again, 760 torr equal 760 millimeters of mercury equal 1 atmosphere. And also, one millimeter of mercury equals 1 torr. And you should know this. And this will be given to you in important information, test 3, but you still should know how to use it, know it exists. Now, there are other units of pressure that people use. We won't be using it in this class, but as I showed you in that barometer, inches of mercury is also a unit, and you'll see that in the, guess what, your weather report. And they'll normally have what's the barometric pressure in inches of mercury. And by the way, and I'll never use this on a test, but 29.9 inches of mercury equal 1 atmosphere. Ooh, let's look at something. And if you notice right now in Chicagoland, I have it set for where I live in Schaumburg, which is just about 15 miles, it's almost east, on the east, what am I saying, north of Glen Ellen. The barometric pressure is 29.97. And if we look at the definition, we're pretty close to sea level pressure right now. Now, another unit of pressure is called pounds per square inch. Remember, pounds, force per unit area. And it's abbreviated PSI. Now, where you're going to see PSI in your daily life is in your car tires. I bet you never thought your car tires, or if you don't own a car, your friend or parents' car tires, or if you take a bus, the bus, or see a truck, the car tires or bus, train, or not train, car or bus or truck, the car tires have gas inside. Now, for many, many years, and they still do, they use air, you know, what's around you right now. And number of years ago, somebody got inventive to make more money. At least that's my personal opinion. And now you can go to your dealership, instead of putting air in there, they put nitrogen. Now they say that's better for your tire. Now, as an organic chemist, which I am, oxygen will attack your rubber, your tire with time, and it will harden and decompose. But it takes a long time. And having inside under pressure, quote unquote, accelerates it. Not really, but Your car tires, you measure the pressure. We'll talk more about it this chapter. And I hope you do at least once a month, or if you have the newer cars, the number of years, I have an older one, I still have to use a gauge. Check your car tire pressure. Mine are at 35 PSI, which is about double atmospheric pressure at sea level. And because they're at a higher pressure, the gas presses out inside the tire, and that's how it stays inflated. But you never thought you'd hear about car tires in chemistry class. We haven't even gotten to the good stuff yet. And also in the chemical industry in the United States, you do what's called high pressure reactions, which I have done both in a lab and supervised in a chemical plant. And notice 1 atmosphere is 14.7 PSI. I've been working in high pressure chemistry, doing what we'll call hydrogenations, and I'll talk about that later in the semester, at about 600 to 800 PSI. And when you're at that high of pressure, things get interesting and dangerous if you're not careful. All right, it's pressure practice time. And the first one is, how many torr is 452 millimeters of mercury? That's not what I wanted. Now, I'll write up here because you'll be given this. And this is for pressure. Now, this is what I'll have on important information test number 3, but implicit in there is 1 millimeter of mercury equal 1 torr. So how do we begin? Well, what are we being asked to find? Torr. What are we given? And 354 millimeters of mercury. Now, this is the only number we have. And if I could multiply it by some ratio, what do I want to get to? Well, right here is torr. And guess what time it is? I bet you thought we were done with that. No, it's time for your good buddy, your good friend, unit analysis. And how do you use that? Whatever you're trying to get to, the units go on top. Whatever you're trying to get rid of, the units go underneath. Let's write it in. And where do we get these numbers? From right here. Now you can put 1 and 1 or 760 and 760. I'm going to put 760. And notice millimeters of mercury divided by millimeters of mercury cancel out, because anything divided by itself equals the number 1 is gone. And remember, these are exact numbers, both, because this is a definition, not a measured quantity. Therefore, they cancel out. I'm going to use my mental calculator, and you get 354. All right, your turn. All right, your turn. How many millimeters of mercury is 842.6 torr? I think everybody's just about done. I'll give you another 8.6 seconds. 8.2, 8.4, 8.5, 8.57. Time's up. All right, what are we trying to find? How many millimeters of mercury? What are we given? And now, this is the only number we have, the torr, so I'm going to start with that. If I had some ratio, I could multiply this by to convert to my units of answer. What units do I want my answer to be in? And millimeters of mercury. And now I'll use unit analysis, my good buddy, my good friend, whatever units I'm trying to get to go on top, whatever we're trying to get to goes underneath. And I'll write it in. And where do I get these numbers? Well, if we scroll up, 760 millimeters of mercury equals 760 torr. So 760 millimeters of mercury equals 760 torr. And notice torr divided by torr cancel out because anything divided by itself equals 1. I'm left with the right units. This cancels out. And remember, these are exact numbers. This is 4 significant figures. My answer better be 4. In this case, it is. And let's see what number I use. All right, let's look at this one. How many atmospheres is 832 millimeters of mercury? Good question. Thank you. Remember, atmospheres is a unit of pressure for gas. What did I have? 832. All right, now how do we proceed? Well, what are we being asked to find? How many atmospheres? And I could put down how many atmospheres oxygen is 832 millimeters Hg oxygen, but for now, this is all right. And what are we given? And so this is the number we have to start with, 832 millimeters of mercury, of pressure. And what am I trying to get to? Atmospheres. And now, if I have a conversion factor ratio, how do I set that up? I use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. I'll write those in. And where do I get these numbers that go in there? I come up top and look, 760 millimeters of mercury equals 1 atmosphere. Again, 760 millimeters of mercury equals 1 atmosphere. So for every 760, hold on, oh no, every 760 millimeters of mercury, I have 1 atmosphere. Now, before I pick up my calculator, millimeters of mercury divided by millimeters of mercury cancel out because anything divided by itself is 1. I'm left with the correct units. And don't forget, this is an exact number, and this is an exact number. The only number I use to determine my answer significant figures is this number right here, and that's 3 significant figures. I hope you all know how to do that by now. And now I'm going to pick up my calculator. And my calculator gives me the following number. Talk about a lot of numbers, and I'm going to let you do this. Is an interesting one. You round that off to 3 significant figures. Your turn. Give you 3 more seconds. 2.73. All right. Keep the 1, keep the 0, keep the 9. That's my 3 significant figures. Use the 4 to round off. Is that 4 or less? Obviously. 4 or less. I drop all this. And the answer is this. And I'm going to let you try one. But first, let me write this so you can see it, because I'm not asking you to memorize it like I did in the past. Everybody read, do I have to print out torr, T-O-R-R? So used to writing it, I'm going to have to train myself. All right, your turn. How many atmospheres is 856.77 torr? All right, I think everybody's done. Let's get going. So what are we being asked to find? How many atmospheres? What are we given? How many torr? And therefore, this is the only number I have to start with, so I will. And if I had a conversion ratio, what units do I want my answer to be? Atmospheres, ATM. And now you will use our good buddy, our good friend, unit analysis. Whatever I'm trying to get to goes on top, units. Whatever I'm trying to get rid of go underneath. I'll write those in. And where do I get these numbers? Oh, look, someone was nice enough to write here. 760 torr equals 1 atmosphere, and therefore I have this ratio. Remember, both of these are exact numbers. Ooh, look at this one. It's 1, 2, 3, 4, 5 significant figures. So before I pick up my calculator, notice torr divided by torr cancel out. So I know I'm going to get the right units. And now I'll pick up my calculator, 856.77 divided by 760. Oops. And my calculator gives me the number . And I'll let you round that off to 5 significant figures. I don't think I've done one like that yet this semester. Wow, 5 that's pretty significant. Oh, that was an awful joke. All right, let's do it. Keep 1, 2, 3, 4, 5 significant figures. Use the 8 to round off. Is that 4 or less, 5 or higher? 5 or higher. I'm going to drop all that, increase this by 1. So the correct answer is 1.1274 atmospheres. Oh, let's do one more. These are fun. And here's one more for you. How many torr is 1.82 times 10 to the third atmosphere? And I'll rewrite this again. And have fun. And while you're doing that, I'm going to look at something interesting for me. And if you can see, everybody, tonight, if you're in a gambling mood, the Powerball is up to 685 million. If you win, don't forget to remember Dr. White. Also, if you want, in chat, if you have a lucky number, email it to me and I might buy a ticket. If I win, I'll remember you too. I'll take you out to dinner. I've got a favorite place in Amsterdam. Another favorite place I haven't been to in ages in Cologne, is Cologne. And also another favorite restaurant I haven't been to in ages, and it's called München. You know it as Munich. Those are in Germany, the other is in the Netherlands. All right, let's do the poll. And it looks like everybody's done, so I can get started. All right, what are we being asked to find? How many torr? What are we given? Remember, torr is named after, they call it physicists. I like just calling him a chemist. I guess he was a physicist. Torricelli, the great Italian scientist who invented the barometer, which is the first way to measure pressure of a gas. And that was atmospheric pressure. And we're given this number. And therefore, this is the only number we have to start with. If I have some ratio, I can multiply and convert it. What do I want my units of my answer to be? And that's torr. And now I'll use my good buddy, my good friend. Anybody keeping count how many times I've said that this semester? Unit analysis, whatever I'm trying to get to, the units go on top. Whatever units I want to get rid of go underneath. I'll write that in. And where do I get these numbers? From right here. 760 torr equals 1 atmosphere. So for every 1 atmosphere, we have 760 torr. These are both exact numbers because this right here is a definition, not a calculated number. And this is an exact number. So therefore, this is 3 significant figures. My answer will be 3 significant figures. And now I'll clear my calculator. Ooh, scientific notation time. Remember, don't forget, use the second key, double E. And that's 3 times 760. And my calculator gives me this number. And on test 3, and it'll also say on test 2, please use proper significant figures for all calculated answers. And this is one that's calculated. And how do we use it? Significant figures? When you have a multiplication division, then your answer has the same number of significant figures as the number that has the fewest significant figures. This has 3. This should be rounded off to 3 significant figures. Keep the 1, keep the 3, keep the 8. The 1 to round off is 3, that's 4 or less. I'll drop that. And the correct answer is 1.38 times 10 to the 6. And our units are torr. And that's how you do pressure conversions, which you should know how to do for test number 3. All right, we've done our practice time. Let's move on. Now, before I do the slide, I need to talk to you about something. Long time ago, late 1600s, early 1700s, I think it started in England, but I'm not a historian. Hold on, tea time. In England, and really in Europe, it started, I think, again, I'm not a historian, was the Industrial Revolution. And what was important about the Industrial Revolution is mankind, or I guess I could say womankind, not to be sexist, but personkind. Is that, I guess that's why I just made up a word, if not. But anyways, having energy to do things quicker fueled the Industrial Revolution. That means they could make things quicker, better, more of them, and cheaper by making things in quantity. What was one example? Well, this isn't wool, but yarn in England that made them a powerhouse, where they could make woolen yarn to make wool and things like that. And that was all based on power. The original power was a water wheel. And if you see on the screen, there's a water wheel. It'd be next to a river, and it would turn, the flow of the river would be move these paddles, and that could be attached to gears that move ropes or other belts to make equipment move. That was original power source. And in the United States, that was used heavily in our 1700s to help fuel the Industrial Revolution. But one of the great inventions that helped move things forward was the steam engine. They have some pictures here, like this one. Instead of having water turn a wheel that turned, you could capture the energy of that wheel turning, you had a steam engine. And here we have a piston where you had steam fill that and empty, and would drive the piston back and forth, which would turn the wheel to provide energy. Now, what's steam? Well, steam is just high temperature water as, surprise, a gas. And because of that, understanding how gases react or interact or change certain parameters in a certain conditions, like in a piston, steam engine, was very important and also very lucrative if you could figure out things. And back then, as now, a driving force in research how to figure out things is money. I don't know if you remember that, going like this if you have some dollar bills, but moolah, cash. And where was this most heaviest use of the Industrial Revolution? And that was England. And in England, a number of great scientists or chemists, I call them, I don't know if they were really called chemists back then, but came up with what is known as the gas laws. First of all, a law is something that's always true, always. If it's not always true, it can't be called a law. And the gas laws were various mathematical relationships. Relax, take a deep breath, let it out, that help people understand what was happening in a cylinder with the steam. And later on, the same thing with gases in a cylinder was true with the combustion engine, otherwise known as the gas engine. And that's like the engine in your car. And being able to predict what happens under different conditions when the piston goes back and forth and affects the gas in the piston is very valuable to know. And the first of those that I'll talk about gas laws is Boyle's law. Guess who discovered this? Boyle. Now, I'll never ask you what are the words, but the volume of a gas sample of gas is inversely proportional to the pressure applied to the gas if the temperature is kept constant. Now, important thing about Boyle's law is temperature is kept constant. Now, a way of writing Boyle's law is P1 times V1 equals P2 times V2. What's that? Well, let's take a look. P1 is the initial pressure. V1 is the initial. I can spell it correctly. Volume. I think I told you more than once, I was always first one down in a spelling bee. P2 is the final pressure. And V2 is the final volume. And based on Boyle's law, if you're given initial pressure, volume, and one of these, you can figure out the other. Either pressure you're given, you can figure out volume, final volume, or if you're given final volume, you can figure out final pressure. If I look at the time, we're just about out of time. So we'll get back to this on Wednesday. Tomorrow, I will go through chapter 5, part 1, practice problems. Do them. If you have questions, ask. Remember, in my class, there's no such thing as a dumb question ever. Also, don't forget today from 5 to 6:15, I will have my office hour, and luckily nothing's going to interfere, so I will be there. Trust me, I will be there. If you need help with anything, including if you haven't handed in all the labs, this morning I sent out an email to anybody who who are missing labs that you need to get them in, because after Thursday, I'll put a 0 in for any missing labs. And with that, I'm done. I'm out of time. Gang gesund, be healthy. I'll do it the special way. Gang gesund, be healthy. Have a nice day. I'll see you tomorrow unless you come to my office hour.